Hi everyone, welcome to this C++ features. My goal is to help you write efficient C++ code. And in this video, we're going to discuss the topic of aliasing in C++. So suppose we have this complex type. You don't have to know what it does. But what if we have shortened type, the symbol type, right? So the way how to turn this complex type into the symbol type could be later, right? So we will choose the simple one. And the way to transform this complex type into the simple one is called aliasing. So the aliasing is a useful technique to simplify the complex type. So this increase the readability and reduce the typos. Imagine that in your code base, you have a lot of type definition. If it comes with this complex one, you might come up with a typo. It isn't better to define the simple one and circulate it in your code. So we have two ways to do here. The first one is the typedef, and the second one is alias declaration. If we can use the typedef and alias declaration interchangeably, so how they different? So I'm gonna start with typedef. So to do the typedef, they have the disadvantages. You know, but the first thing I would like to show you is how to define, how to use the typedef keyword. You see on my screen, and this line, we have the typedef keyword followed by the complex type and followed by the simple type the name of the type that we want. So we have three parts here, right? This is how to define the typedef. So this is a simple case. But what if we want to do it like this with template? I will comment out. So we have the template definition and also the type definition. Right? The type that we want is wake structs. So I'm going to compile it. See, we have error here. A typedef cannot be a template. So the disadvantage is that typedef in template need to define it inside struct or class. So in order to use this properly, you need a workaround. So to work around, you need to define it like this. We have the template definition and also struct name dmap in this example. And inside the struct, you define the typedef as usual, or you define the typedef within the class. In this class example, we have the template definition and also the class map, and use the typedef within the class like this, called map type. So with this one, we'll see if what's showing on terminal. Oops, what is error? So sorry. Sorry. Oops. I forgot to uncomment this one. Okay. Let's compile it again. See, you don't have any errors. So that is the first disadvantage of typedef. But the second is that if you suppose you have this struct, you define the typedef within this one. So that means the type that you want is in the struct. So it's dependent with the struct. If you want to use this dmap inside this class map, what you need to do is that because this is dependent type inside the struct, you need to include the keyword type name to use it properly. If I is happen to be that I don't include the type name, what's going to happen? I compile it. So it's an error, but it has warning that the type name prior to dependent type name. So, but it is an implicit type name in C++20. But we want to clear this warning or use this properly. That's why we need to have the type name here. And that is the cumbersome and the second disadvantage of typedef. I'm gonna let you through the real code example. In this example is from navigation to package. Well, so this is a simple one because they define the type depth not within the class, not within the template. So it's simple. The second example, shows that they define the type depth, a lot of type depth. So this is inside the template class. So notice that if it happens to have the dependent type like this, um, uh, this coordinate vector and iterator, whatever name is, depends on the template type, node T, right? So this you need to include the type name, right? So and coming with alias declaration. So this one is more modern way in C++. So the uses that they use the using keyword with the simple name that whatever name you want and the equal sign and the complex type here. So in this example, I have the UMAP SS to this simple type, same for this one. Hide and no errors, right? So it is suitable with template. That's why it's in modern C++. So for example, if I have the template definition here, and I define the by alias type here, so it is directly under the template. And this one works. So this one works. I compile it without any error. And if it happens to me that I want to use this alias type UMAP within another class, another template class, this class map, since it is it defines it directly with template, doesn't have instruct or in class, so it is non-dependent type. I can use it directly like this without the keyword type name. This is more like convenient, right? So combine without any errors. So let's see in the real world code. So it is a code from Eggman OS Beluga for localization. So this one, they use the alias type inside the template class, right? This is a normal use when the complex class and they want to use a complex type that is seen for the type that is more complex short in the name. And you see, notice that if the complex type is the dependent type, which depends on the template parameters here. So you need to have the type name. But by the way, this is a more modern code. I use the type alias. And another example is that they also use the alias type in the template function. With this one, it doesn't have the dependent type. It's used directly the template parameters here. So that's why it don't have the type name in the front. So that's all the use case and the differences between typedef and alias declaration. So my suggestion is to use the modern way, which is use the alias declaration and stick to it. Thanks for listening.